Hi guys, I'm Sankal and today we are going to learn about network software. So let's get started. In this video, we're going to cover these topics: protocol hierarchies, design issues for the layers, connection oriented versus connectionless services, service primitives, and the relations of service to protocol. We'll be discussing all these topics in brief and some in detail. So let's get. So what is a network software? Network software encompasses a broad range of software used for designing, implementing, operating, monitoring computer networks. Traditional networks were hardware-based with software embedded. With the advent of software-defined networking, software is separated from hardware, thus making it more adaptable to ever-changing nature of computer networks. Network software is now highly structured. In the following sections, we will examine the software structuring technique in some detail. Protocol hierarchies. A protocol is a set of rules and conventions agreed upon and followed by communicating entities for data communication. A protocol outlines what, how, and when of a communication. The three aspects of protocol are syntax, it defines the format of data that is to be sent or received. Semantics, it defines the meaning of each section of bits that are transferred. Timing, it defines the time at which data is transferred as well as the speed at which it is transferred. Most of the networks are organized as a stack of layers on top of another. The number of layers and their names vary from network to network. Each layer has specified function addressed to specified protocols. Thus, we obtain a stack of protocols. This is a diagram for protocol hierarchies. We will be explaining this in the further slides. The diagram is a five-layer network and shows the communication between host 1 and host 2. As data stream is passed from one host to another, it goes through several layers. Virtual communication is represented using dotted lines between peer layers, while physical communication is represented using solid arrows between adjacent layers. The actual communication occurs through physical medium. Layers at the same levels are called peers, which have set of communication protocols and interfaces present between each layer, which is used to explain the services provided by the lower layer to the higher layer. Yeah, like I will be explaining all those things in detail again. The entities comprising the corresponding layers on different machines are called peers. The peers may be software processes, hardware devices, or even human beings. No data are directly transferred from layer N on one machine to layer N on another machine. It is transferred to the physical medium, the actual communication where it occurs. The actual communication occurs in the physical medium. As we saw, the virtual communication occurs, which is showed by the dotted lines. Between each pair of adjacent layers is an interface. The interface defines the primitive operations and services the lower key makes available to the upper one. A set of layers and protocols is called network architecture. The specification of an architecture must contain enough information to allow an implementer to write the program or build the hardware for each layer so that it will directly obey the appropriate protocol. A list of protocol used by certain systems. One protocol per layer is called a protocol stack. This is an example for a protocol hierarchy. Yeah, the diagram is an example for providing communication to the top layer of 5-layer network. A message M is produced by an application process running in layer 5 and given to layer 4 for transmission. Layer 4 puts a header in front of the message to identify the message and surpasses the result to layer 3. The header includes control information such as addresses to allow layer 4 on the destination machine to deliver the message. Layer 3 decides of the outgoing lines to use and pass packets to layer 2. Layer 2 adds each space not only header but also trailer and gives resulting unit to layer 1 for physical transmission. At the receiving machine, the message moves upward from layer to layer with headers being stripped off as it progresses. We'll be discussing the design issues for the layers. A number of design issues exist for layer-to-layer approach for computer networks. We'll be discussing about those issues and what can be done to solve those issues. Reliability. Network channels and components may be unreliable, resulting in loss of bits of data while data transferred. So an important design issue is to make sure that the information transferred is not distorted. Scalability. Networks are continuously evolving. The sizes are continuously increasing, leading to congestion. Also, when new technologies are applied to added components, it may lead to incompatibility issues. Hence, the designs should be done so that the networks are scalable and can accommodate such additions and alterations. Addressing. At a particular time, innumerable messages are being transferred between large numbers of computers. So, a naming or addressing system exists that each layer can identify the sender and receivers of a message. Error control. Unreliable channels introduce a number of errors in data streams that are communicated. So the layers need to agree upon common error detection and error correction methods so as to protect the data packets while they are transferred. Flow control. If the rate at which data is produced by the sender is higher than the rate at which data is received by the receiver, there are chances of overflowing the receiver. So a proper flow control mechanism needs to be implemented. Resource allocation. Computer networks provide services in form of network resources to the end users. The main design issue is to allocate and deallocate resources in processors. The allocation and or the deallocation should occur so that minimal interface among the host occurs and there is optimal usage of resources. Statistical multiplexing. It is not feasible to allocate a dedicated path for each message while it is being transferred from the source to the destination. So the data channel needs to be multiplexed so as to allocate a fraction of bandwidth or time to each host. Routing. There may be multiple paths from source to the destination. Routing involves choosing an optimal path among the possible paths in terms of cost and time. There are several routing algorithms that are used in networking systems. Security. A major factor for data communication is to defend it against threats like eavesdropping and many alterations of messages. So there should be adequate mechanisms to prevent unauthorized access to data through authentication and cryptography. Connection-oriented and connectionless services. In order to establish a network connection between two or more devices, there are services in computer networks. There are two services that are given by the layers, two layers above them. These services are as follows, which is connection-oriented and connectionless services. Connection-oriented services. There is a sequence of operations to be followed by the users for connection-oriented service. These are the connections established, information is sent, connection is released. That's it. Connection-oriented service is more reliable than connectionless service. We can send the messages in a connection-oriented service if there is an error at the receiver's end. An example of connection-oriented service is TCP, which is Transmission Control Protocol. And this is the diagram for the connection-oriented service. In the above diagram, a solid line between device A and B indicates that there is a dedicated link with which the stream of data travels between them. With the help of this link, a receiver can send an acknowledgement to the sender about the status of the packets that are being transferred. The advantages. Connection-oriented services are very reliable. There is no duplication of data packets, no chances of congestion, suitable for longer congestion. Connections. Sequencing of data packets are guaranteed. The disadvantage. This allocation of resources is mandatory before the communication, which means we need to allocate the resources, which is kinda risky. The system of connection is slower as the time is taken for establishing the relinquishing the connection. As I said, it takes time and resources before the connection is made. In case of network congestion or router failures, there are no alternative ways to continue the communication. So if there is a failure in if there is a router failure, you can't communicate. The connection is cut off there. Connectionless services. It is similar to the postal services as it carries the full address where the message is to be carried, just like letters. Each message is routed independently from source and destination. The order of messages sent can be different from the order received. In connectionless service, the data is transferred in one direction from source to destination without checking the destination is still there or not, or if it is prepared to accept the message. Authentication is not needed in this. An example of connectionless service is UDP, User Datagram Protocol. Yeah, this is an diagram. This is the diagram for connectionless services. So you can see that this is device A and device B. As we discussed earlier, the packet that are sent is not same as the packet that I received. As we can see, packet 1 and packet 2 are lagging behind packet 3, which was sent after packet 1. So these are this this is how it works. Advantages. There are usually two overheads. Connection-oriented services help to broadcast or multicast messages to multiple recipients, whereas connectionless doesn't. In this, there is no circuit setup, thus it takes a fraction of a minute or order to establish a connection. In case of network congestion or router failures, it has an alternative path for data transmission, whereas connection-oriented doesn't have. If there is a failure in router, the connection is stopped, but this has an alternate method or path. Disadvantages. These are susceptible to congestion in a network. It is not reliable as there is a possibility of loss of data packets, wrong delivery of packets, or duplication is high. In this, each packet needs lengthy fields because they are supposed to hold all the destination address at the routing information. Service primitives. A service is formally specified by set of primitives or operations available to the user or entity to access the service. These primitives tell the service to perform some action or report on an action taken by peer entity. One way to classify the service primitive is to divide them into 5 classes. Listen, connect, receive, send, and disconnect. Listen, a block waiting for an incoming connection. Connect and establish a connection with a waiting peer. Receive, a waiting block for an incoming message. Send a message to the peer, as simple as it is. Disconnect, terminate the connection. Simple. The first server executes listen to indicate that is prepared to accept the incoming connection. A common way to implement listen is to make a blocking system call. After executing the primitive, a server processes a block until a request for connection appears. Client process executed connect is established to the connection with server. The connect call needs to specify who to connect parameter given to the server's address. A simple client-server interaction using the acknowledgement datagrams. I'll explain this figure. The operating system sends the packet to the peer asking it to connect as shown in the figure. That's the making the connection. That's the first one. The connection process is connected until there is a response. When the packet arrives at the server, it is processed by the operating system. When a system says the packet is requesting a connection, it checks to see if there is a listener. Unblock the listener and send back the acknowledgement. That's the second step. The arrival of acknowledgement releases the client. At this point, the client and server are both running and they have connection established. The next step for the server to execute receive is to prepare to accept the first request. The server does this immediately upon being released from the listen before the acknowledgement can get back to the client. The receive call blocks the server. The client executes send to transist the request. That's the third step, followed by executing to receive to get a reply. The arrival of the request packet at the server machine unblocks the server processes so it can process the request. After it has done the work, it uses send to return the answer to the client. That's the fourth step. If it is done using, if it done, it use disconnect to terminate the connection. And initial is blocking a call is a blocking call, suspending the client and sending a packet to the server saying that the connection is no longer needed. When the server gets the packet, it also issues a disconnect of its own, acknowledging the client and releasing the connection when the server's packet gets back to the client machine. The client process is released and the connection is broken. The relationship of services to protocols. Service. Services are the operations that a layer can provide to the layer above it in the OSI reference model. It defines the operation of states a layer is ready to perform. It does not specify anything but the implementation of these operations. Protocols are a set of rules that govern the format and meaning of the frames, messages or packets that are exchanged between server and client. So this is a simple example of relationship between a service and a protocol. As we can see there, this is the service provided by a layer K, and it has a protocol which are some conditions, and this layer receives it. Simple. Thank you guys. Please like and share.